First, let's review what a parabola is. Using a conic section, we see that it is the line represented by the edge of a slanted cut on a cone. Because the cut must be parallel to the surface or slope of the cone, then the parabola ends at the circle represented by the bottom of the cone. In physics, it is the path created by the force of gravity on an object thrown, disregarding, of course, any other forces such as wind. So a parabola must turn at some point, and after it turns, it repeats the same path going in the opposite direction. That is why the path of a parabola is symmetrical. The area of this half is identical to the area of this half. And of course, the center line is called the line of symmetry. Besides an object in flight, many conditions show parabolic behavior. For example, in economics, the total cost curve is a parabola that comes down and turns up. Therefore, an important part of the parabola is the point at which it turns. And the point at which it turns is called the vertex. When the vertex points up, we call the vertex the point of maxima. And when the vertex points down, we call it the point of minima. Let us now work out the standard vertex equation of the parabola. Starting with the standard equation of the parabola, y equals ax squared plus bx plus c, where a, b, and c are coefficients, we realize that the y-axis of the graph is parallel to the axis of symmetry of the parabola, and that the x value of the vertex can be seen as a value either on the y-axis of the graph when it is 0 or to the right or left of the y-axis. First, we now look at the parabola equation and discard the c value. We do this because the c value determines the up and down or y value of the vertex, and it has no bearing on the value of x, whose value is determined left and right. So, dropping c, we get that y equals 8x squared plus bx. Now we want to find the zero values of x. Or, in other words, we want to know what are the values of x when the parabola crosses the x-axis. You see, if we know the values of x when y is 0, all we have to do is find the average of the two values, and the average has to be the vertex value of x because parabolas are symmetrical. So, we take the y equals ax squared plus bx equation and factor x, giving us y equals x times ax plus b. We find the zero values by saying 0 equals x and 0 equals 8x plus b. Solving for x, b becomes negative b on the other side and a is divided. So these are the x-intercept when the value of y is 0. But we want the value at the center of this line. So we divide negative b over a by 2, and the standard equation to find the x value of the vertex of a parabola is x equals negative b over 2a. Does this equation work even if the parabola doesn't have zero values for x? In other words, if it doesn't have real solution because it never crosses the x-axis? The equation works for all parabolas because the c value is not part of the calculations, as parabola may be translated up and down. Let's see a couple of examples. Find the vertex of the parabola y equals x squared plus 4x minus 5. Using the standard equation as reference, we see that a equals 1 and b equals 4. Substituting in the equation x equals negative b over 2a, we get that x equals negative 4 over 2 times 1, or negative 4 over 2. The value of x for the vertex is negative 4 divided by 2, or negative 2. Going back now to the original equation, we find the value of y because we now know x. When x is negative 2, y equals negative 2 squared plus 4 times negative 2 minus 5. Negative 2 squared is 4. And 4 times negative 2 is negative 8. So 4 minus 8 minus 5 equals negative 9. The vertex is at negative 2, negative 9. The next one is find the vertex for the parabola y equals negative 2x squared plus 3x plus 2. Using the standard equation as reference, we see that a equals negative 2 and b equals 3. Substituting the equation x equals negative b over 2a, we get that x equals negative 3 over 2 times negative 2, or negative 3 over negative 4. The value of x for the vertex is positive 3 divided by 4, or 0.75. Going back to the original equation, when x equals 0.75, y equals negative 2 times 0.75 squared plus 3 times 0.75 plus 2. Squaring, multiplying, and adding, the value of y is 3.125. The vertex is at 0.75, 3.125. Let's see what else we can learn from the vertex equation itself. Examining the standard equation for the vertex, we see that if the value of b is high compared to a, the vertex is farther away from the y-axis. So if b is 6 and a is 1, the x value for the vertex is negative 3. And if b is 16 and a is 2, the value for the vertex is negative 4, and so on. Now, if b is negative and a is positive, the vertex is to the right of the y-axis. If the reverse happens and b is positive and a is negative, again the vertex is to the right of the y-axis. This is so because the equation is negative, and a negative value of a coefficient will turn the value of x positive. However, if both a and b are negative or positive, then the vertex is to the left of the y-axis because the equation stays negative.